Now, questions from whatever we did in the last class? Yes. All right, I'll explain that. So, in my last class, serious? So, in my last class, I gave you certain basic rules of differentiation. And towards the end of the session, I gave you the chain rule, and then we discussed things like logarithmic differentiation, etc. So now, if we had a function y equal to fx, which is a power x, and I want to differentiate y with respect to x, where a is a constant, then log y is x log a. ln a means log a to the base e. Log a to the base e. Now, if a is a constant, log a is also a constant. If a is a constant, so is log a. Now, if I differentiate log y with respect to x, what do I get? 1 by y dy dx. 1 by y dy dx. 1 by y dy dx. So let me differentiate both sides with respect to x, right? So ddx of log y is ddx of x ln a. Now ln a jumps out of the derivative sign. Why? Because ln a is a constant. So ln a ddx of x. Hey, but what's ddx of x? 1. ddx of x is 1. So this becomes like a ln a, right? And then the left hand side is 1 by y dy dx. ddx of ln y is like a 1 by y dy dx, leading to dy dx equal to y ln a. But what's y? A power x. So that makes it a power x ln a. A power x ln a. Right? So ddx of a power x is a power x ln a. ddx of a power x is a power x ln a. Yeah, anything else from the previous class? No? So now the first thing that I want to do is, I want you to just get warmed up with whatever we did in the last class. I'll write down a set of problems for you. You differentiate y with respect to x, and then once you know that you are comfortable with all of this, I'll move on to integration. How about it? Yes. Very quickly differentiate these 5 and then I'll discuss these 5 and then I'll give you some more. So, and one thing if you recall, ddx of log y is 1 by y dy dx, right? What is ddx of tan y? Sec square y dy dx. Sec square y dy dx. What is ddx of e power y? E power y dy dx. E power y dy dx. And so on and so forth. Now carry on with this stuff. Carry on. Real fast. But all of you should do everything right here. The first one, dy dx. Like I said, chain rule, go from outside to inside. E power would give me e power. So that's going to give me e power cos of x cubed. Then come to cos. Cos will give me minus sine. So into minus sine x cubed. And then x cubed would give me? Absolutely. I hope all of you got this right. Good. Two. Cos y is ln x squared plus x. Okay. So now we differentiate both sides with respect to x. ddx of cos y is like a ddx of ln x squared plus x. Right? Hey, what's ddx of cos y? Minus sine y dy dx. Right. Now, ddx of ln of this. So, outside to inside, ln would be 1 by. And then, x squared plus x would be? Absolutely, 2x plus 1. Right? So, that gives me like a dy dx equal to minus 2x plus 1 divided by x squared plus x sine y. Right? And sine y you can write as root 1 minus cos squared y, where cos y is this. So you could have written it entirely in terms of x, because sine y could be written as root 1 minus cos squared y, where cos y is this. Right? Nahin? What did you not understand? I said cos y is this. What sine y? Sine y is root 1 minus cos squared y, where cos y is this. So you could have written sine y exclusively in terms of x. Right. Sometimes it may not be possible to do that. Sometimes you may not be able to isolate x and y. Alright, but in this case you can. In this case you can. Then e power y is sine of ln x. If you differentiate e power y with respect to x, what is it that you get? E power y dy dx, right? E power y dy dx. And then go from outside to inside. And then ln x. Right. So we get dy dx equal to cos of ln x divided by x e power y, where e power y could be substituted by sine of ln x and you could get it. Right? So that's dy dx. And then the fourth one. Y is sine of e power cos of x power 5 plus x. So dy dx, sine is going to give me cos. E power will give me e power. Cos will give me minus sine. And x power 5 plus x is going to give me plus 1. Absolutely. That's dy dx. We've all got it right? Good. Now, y is sine e power x plus cos x whole to the power m. Right? Again, go from outside to inside. Dy dx. This is something to power m is going to give me m into something to power m minus 1. Right? And then sine will give me cos. Then e power x plus cos x will give me precisely. Very good. Very good. Right? So now you've learned to differentiate between the good and the bad. Okay. Okay. So let's flex our mental muscles a little more now. Same thing. But yes. Cos y is ln huh.
I've done it the other way. Y is equal to cos inverse.
Perfect. You could have done that. I'll tell you what he did. Yeah, you could. Yes. This is what he did. Cos inverse ln x squared plus x. Now dy dx. Go from outside to inside. Cos inverse would give me minus 1 by root 1 minus square of that. Right? So minus 1 by root 1 minus ln x squared plus x whole squared, right? That's cos inverse. Now go inside. Ln would give me 1 by x squared plus x, and then x squared plus x gives me 2x plus 1. What's your name? Vedant. Good, Vedant. Right. Fair enough? Let's take a few more. Okay? So far so good, right? You're very transparent about whatever we've done so far in differentiation, right? Take some more then. Find in each case dy dx given a condition. Now, I'll give you a condition, a relationship, and from there you would have to scoop dy dx out, right? Say if x power y is y power x, find dy dx. 2 sine of x plus y is e power x. 3 sine x squared plus x whole to the power y is x. Okay, take these three and find dy dx. Now let me just get you triggered into the game. For example, say if I had sine x to power y is cos x, for example, and I had to find dy dx out of it. Or let me make it a little more filthier. Cos x to power x. Okay. And I had to scoop dy dx out of this relationship. This is a relationship that I'm giving. Now, I'm not explicitly defining y as a function of x. This is an implicit relationship between y and x, where either you would have to separate y from x with an extra effort, or without separating y from x, you would have to find dy dx, which could be either in terms of x or in terms of y or in terms of both x and y, right? So in any case, let's attempt to differentiate both sides with respect to x. Let's first take logarithm of both sides to get rid of the powers. To get rid of the powers, let's take logarithm of both sides. So y log cos x is x log cos x. How about this? Oh, sorry, sin x. Sin x. Right? Now in this case, fortunately for us, I can separate y from x because y is written as x log cos x divided by log sin x. Right? I can separate y from x in this case, isn't it? Now, realize that this is a ratio of two functions. So to find dy dx, I'm going to apply the quotient rule. Quotient rule, derivative of numerator into denominator minus derivative of denominator into numerator divided by square. Right. So then, to find dy dx, the derivative of numerator, ddx of x ln cos x into denominator, which is ln sin x, minus ddx of ln sin x, ddx of ln sin x into numerator, which is x ln cos x, divided by denominator squared, ln sin x whole square. So far so good? Now, what is this? This is product of two functions. Derivative of x into this plus derivative of this into x. Right? Product of two functions. Derivative of the product is derivative of first function into second function plus derivative of second function into first function. Same here. Now in this case there is no product rule. There is only chain rule to be deployed here. Fair enough? So then, in this case, derivative of x is 1. So 1 into second function, right? ln of cos x. Now, plus x into derivative of this, right? Plus x into derivative of this. But what's derivative of this? 1 by cos x into minus sin x. Derivative of ln cos x now. See, go from outside to inside. Outside, ln would give me 1 by cos and cos will give me minus sin. Minus sin x. Into ln sin x. Into ln sin x. Minus the ddx of ln sin x is 1 by sin x into cos x. Right? That makes it cot x. That makes it cot x into x ln cos x. And then the denominator maintains status. The denominator is ln sin x whole square. That's dy dx. That's dy dx. How about it? You can simplify, but don't bother about that right now. This would be the structural looks of dy dx. How many of you don't understand one or more things here? I'll illustrate a little more though. But so far so good, right? Sure about everything that I've said here? ddx of x ln cos x, derivative of x into this, which is this, plus derivative of ln cos x. Ln cos x is this into x.
What is x by cos x?
ddx of x ln cos x. All right. That's ddx of x into ln cos x plus x into ddx of ln cos x. Derivative of first function into second function plus derivative of second function into first function. This is 1 into ln cos x, which is the first term, and then second term x, which is this, right, into derivative of the second function. Got me? Are you all certain about this? can I wipe this off? And let me illustrate a little more. You know, in this case, of course, it was not strictly, see, when you can't separate y and x, then that kind of a relationship is called an implicit relationship. Implicit relationship. Whereas, when y could be separated from x, for example, if I say y is sine x, y is separated from x, that's an explicit relationship, right? We've learned how to deal with explicit relationship. This also looked implicit to begin with, but could be made explicit because y could be separated from x. All y on one side and all x on the other side, and dy dx appeared exclusively in terms of x. So that's the explicitness about this situation, right? But then there could be implicit situations where x and y are together at birth and they can't be separated. All right? For example, something like this. X power sine y is x plus y to power y. Horrendous task to really separate x and y, but dy dx is still within reach. Now, the moment you encounter powers of this kind, the first thought that would burgeon in you would be to take the logarithm so as to make the expression look more fluid. Okay, so let's take the logarithm of both sides to begin with, right? So then when I take logarithm of both sides, then I get like a sine y log x is y log x plus y. How about this? Does it make sense? Okay. Now, for sure, I can't find y exclusively in terms of x. It's like sine y by y is ln x, etc. This, but I can't separate y from x. There is no opportunity for me to separate y from x. So this kind of a relationship is fundamentally an implicit relationship. This is implicit, where y and x stay together. I can't separate y from x. I can't write y on one side and x on the other side exclusively. Then that's the implicit quality of the relationship. That's the implicit quality of the relationship. Now, in any case, dy dx is still within reach. Let's attempt to find dy dx. What we do here is ddx of sine y ln x, ddx of sine y ln x is ddx of y ln x plus y, y ln x plus y, right? Now, I'm going to apply product rule of differentiation. Derivative of this into this plus derivative of this into this. So, ddx of sine y, derivative of first function into second function plus derivative of second function into first function, right? Derivative of the product of two functions. That's the left hand side. And then the right hand side, again I'm going to deploy the product rule of differentiation. Product rule of differentiation, which means ddx of y into ln x plus y, derivative of first function into second function, which is this, plus derivative of second function into first function. So y into ddx of ln of x plus y. Does it sound all right? Now, this is ln x. What is ddx of sine y? Ddy of sine y would be cos y, but ddx of sine y would be cos y dy dx, cos y dy dx. Right? ddx of sine y would be cos y dy dx, right? So we end up getting, for example, ln x cos y dy dx plus sine y into, what's ddx of ln x? 1 by x is ln of x plus y into dy dx plus d dx of ln x plus y. Now the next job is d dx of ln of x plus y. Let's see how we could reconcile with this. But so far so good, right? This last element is something that I want to demonstrate separately, right? d dx of ln of x plus y. Are you all okay with this so far? Okay. Now just the last part, which is d dx of ln of x plus y. Go from outside to inside, chain rule. Ln would give me 1 by, right, 1 by x plus y. And then come to terms with x plus y. d dx of this. The next would be d dx of this. d dx of this would be d dx of this, which is 1, plus d dx of this is d by dx. How about this? You know what I did here? Nahi na? Chain rule. Go from outside to inside. Ln gives me 1 by, and then come inside. Inside would be d dx of this. d dx of this would be d dx of x, which is 1, and d dx of y, which is this. Are you all there with me? Okay, so plus y times by x plus y into 1 plus dy dx. Right? And now what you may want to do is collect the dy dx all on one side. Collect all the dy dx all on one side. This term ln x cos y, ln x cos y, cos y minus ln of x plus y minus y by x plus y. See, this dy dx into this when transposed on this side gives me this. This is what I arrive at on one side. And then on the right hand side, we have y by x plus y, y by x plus y minus sin y by x. So dy dx into this is this. So what's dy dx? This divided by this. That's going to be dy dx. That's going to be dy dx. Are you there with me? What part? Last part I simply said dy dx into this is this. So what's dy dx? This divided by this. And realize the extent of implicitness that it enjoys. You can't even think of separating x and y here. Right? When x was available in terms of y and eventually dy dx in terms of both x and y, God bless you. No further improvement can take place in as far as the looks of this expression is concerned. It's going to stay like this. Be happy. Okay. Okay, now that I've given you some feed on implicit functions, it's about time that you get hands-on with things of this sort. Let me add some more rows y power x. Okay, please try out all of this. So let's sort out these problems. X power y is y power x. Take the logarithm of both sides. So y log x is x log y. Let's differentiate both sides with respect to x. So d dx of y log x is d dx of x log y. And then you're going to apply the product rule of differentiation. So derivative of this into this plus derivative of this into this, right? So derivative of y with respect to x into ln x plus y into d dx of ln x, right? That's the product rule of differentiation. I hope all of you are fine with this. What ln y? Why? It's derivative of y with respect to x into ln x, derivative of first into second plus derivative of second into first. Where is that ln y required? Oh, this one. Oh, this one. Oh, sorry. Okay, just this one. Okay, fine. Sorry? ddx of y ln x is ddx of x ln y. Yeah, what happened here? Yeah, just one side. So, what's the problem? I've not taken the other side yet. Derivative of ln x into y plus derivative of y into ln x. Derivative of the product of two functions, right? Now again the right hand side, again I'm going to deploy the product rule of differentiation. So that's going to be ddx of x into ln y plus x into ddx of ln y. How about this? Derivative of x into ln y plus derivative of ln y into x. Product rule of differentiation for the right hand side. Yes or no? Okay, now the left hand side again. Ln x into dy dx plus y into what's ddx of ln x? 1 by x. ddx of ln x is 1 by x. So y by x is ln y. What's ddx of x? 1 plus x into what's ddx of ln y? 1 by y dy dx. 1 by y dy dx. Okay, might as well put together the dy dx on one side, right? So then you get like a dy dx, all consolidated on the left hand side, gives me a ln x minus x by y, that's the left hand side, right? And then on the right hand side, you just have to comply with ln y minus y by x. So dy dx into this is this. So what's going to be dy dx? This divided by. And there is no opportunity for us to separate y from x here. Let them stay together. What's your problem? Okay? Which is fine. You wrote.
But if I calculate,
You'll have to separate. You'll have to multiply and still collect dy dx, right? Not an issue so far, right? All of you understand everything that I have uttered? People sitting in the rear, can I have you get a little more vocal? Have you understood everything? Now, sine of x plus y is e power x. Sine of x plus y is e power x. ddx of sine of x plus y is ddx of e power x. Now go from outside to inside. I want to differentiate sine of x plus y, not with respect to x plus y, but with respect to x. So let me plunge into the sine first. So from outside to inside, the outermost would give me cos. And then the innermost is x plus y. That means differentiate x plus y with respect to x. So this would give me 1. Absolutely. And then what's the right hand side? E power x, e power x. And then of course 1 plus dy dx is e power x by cos x plus y. Now in this case there is opportunity for us to isolate x from y. Yes?
What I did over there was like to log both sides. So ln of x would be x because ln is 1.
Yeah, but it's all right. It'll still boil down to the same thing. You're right. You could have done that. Right? So I get dy dx plus 1 is this. And now, since sine x plus y is e power x, cos x plus y would be root 1 minus sine squared x plus y, where sine x plus y could be written as e power x. So this becomes e power 2x. So e power x divided by root 1 minus e power 2x. So 1 plus dy dx is e power x divided by 1 minus e power 2x here, right? So dy dx would be this minus 1. dy dx would be this minus 1, etc. Confusion hai kuch? Anyone? Yes. Did you understand this? Then 1 plus dy dx is e power x divided by cos x plus y. Now cos x plus y is root 1 minus sine squared x plus y. But what sine x plus y? E power x. So this is e power x whole squared. But e power x whole squared is e power 2x. Does it make sense to all of you? Clear? Right? And now this one. Take the logarithm of both sides to eliminate the powers, right? So if I took the logarithm here, y log sine x squared plus x is x log y, right? Differentiate both sides with respect to x. So ddx of this is ddx of this. How about this? And then product rule of differentiation to begin with. Derivative of this into this plus derivative of this into this, right? So ddx of y into this ln of sine of x squared plus x, right? Plus y into ddx of sine x squared plus x, right? Now again the product rule applied for this. You confused? Oh, ln, I missed out. Ln sine x squared plus x, right? Right? Again the product rule applied for this. ddx of x into ln y plus x into ddx of ln y. Now this maintains status. So ln of sine x squared plus x dy dx plus y. Now chain rule for this. You want to differentiate with respect to x. So go from outside to inside. So ln would give me, this y is there replicated. So now this 1 by sine x squared plus x. Sine will give me cos. And then x squared plus x would give me? Absolutely 2x plus 1. Now the right hand side. So the right hand side is like ln y ddx of x is 1 plus x. ddx of ln y is going to be 1 by y dy dx. Absolutely. And then like before, by now it's become perfunctory because dy dx you can collect on one side, dy dx into this minus x by y is ln y minus this, and you can solve for dy dx from this. Pretty mundane job to do, right? confusion? Okay, now some more. Sine of xy is cos of e power x to power 10 whole to power 5. ln x by y is e power x sin x. Cos of y by x is e power 2x. Okay, try these. So ddx of sin xy is ddx of cos e power x power 10 whole to power 5, right? Now go from outside to inside. Outermost is sine, that's going to give me cos xy. And then xy with respect to x. That means ddx of xy, right? That's the innermost part of the chain, right? Now go on to the right hand side. Outermost. So 5 into something to power 4, right? 5 into cos e power x power 10 whole to power 4. And then cos will give me minus sine e power x power 10. And then e power will give me e power. And then x power 10 will give me 10x power 9. Absolutely right. Absolutely right. And now the left hand side, just the left hand side. Cos of xy, derivative of the product of two functions, derivative of x into y plus derivative of y into x. Right? Equals the right hand side, whatever it is. Okay? And then this would be y plus x d by dx. So y plus x d by dx would be right hand side divided by cos xy, and you can solve for dy dx minus y. Right. This is ddx of x1 into y divided by x, whole divided by x. Yeah. Fair enough? Now ln x by y is like a ln x minus ln y. That's e power x sin x. Ln x minus ln y, that's e power x sin x, right? Ln a by b, ln a minus ln b. And then ddx of ln x minus ddx of ln y is ddx of e power x sin x. ddx of ln x is 1 by x, but ddx of ln y is 1 by y dy dx, 1 by y dy dx. Now chain rule, e power x sin x, e power x sin x, and then x power x sin x. I'll have to apply Product rule of differentiation, right? The innermost is d dx of x sin x. Right? Is there a confusion? Yeah, you are confused a little bit. No, but you understand what I did here, right? Okay. So now the right hand side is e power x sin x, derivative of x into sin x plus derivative of sin x into x, right? Right? And now things are simple because this is 1 into sin x, this is cos x into x, and you can solve for dy dx. You can solve for dy dx by an ordinary transposition. How about this? Yes, you could have, yes. Of ln of x by y, and then you will have to apply the quotient rule, which is the same thing. But then this is less cumbersome than that. That would be better applicable for the next problem, where the quotient rule comes into being, right? All right, good. Sounds okay? Now cos of y by x is e power 2x. Differentiate both sides with respect to x. d dx of cos of y by x is e power 2x, and then go from outside to inside. Outermost would give me minus sign, and then d dx of y by x. d dx of y by x, that's the innermost part of the chain. d dx of y by x, and that makes it e power 2x is d dx of e power 2x, sorry. d dx of e power 2x. Hey, what's d dx of e power 2x? Into 2, absolutely. I mean, if you differentiate e power 2x with respect to 2x, then you will get e power 2x. But you want to differentiate e power 2x with respect to x. So if you want to differentiate e power 2x with respect to x, you will go from outside to inside. Outermost is e power 2x, then come to 2x. 2x with respect to x would be 2. So d dx of e power 2x would be 2 e power 2x, 2 e power 2x, and that's the right hand side. Right? And now minus sine y by x, derivative of numerator into denominator minus derivative of denominator into numerator divided by denominator squared. Derivative of numerator into denominator minus derivative of denominator into numerator divided by denominator squared. That's the left hand side, and the right hand side is 2 e power 2x. And then now this would be d dx of x 1 into y, and you can solve for dy dx from this. You can solve for dy dx from this, and you get the. Got it? Good. So by this time you would have reached a certain level of accomplishment in differentiating functions of various kinds. In fact, you can differentiate a function of any kind right now, given the exposure that we have received in the last 2 classes, inclusive of the class today. I don't think you would face any intellectual barrier when you have to differentiate a function, no matter how horrendous it looks, right? You've got exposed to explicit differentiation, you've got exposed to implicit differentiation, right? So we are on with the business of differentiation. Now let me give you the other aspect of calculus, which is integration. All right. Again, each of these could be looked upon in very many ways, and we would look upon integration as an inverse of differentiation. So let me explain things to you first. And of course, needless to say, all of you remember all your basic results in differentiation, all the basic results in differentiation, right? Now, when I write something like this sign is called the integral. This sign is called the integral. And I write integral cos x dx. The meaning of this statement is, or the inquiry made by this statement is the following. This means find a function. The statement is find a function which when differentiated with respect to x, this x gives cos x. Find a function which when differentiated with respect to x gives cos x. What function when differentiated with respect to x gives me cos x? Sin x, right? The function which when differentiated with respect to x gives me cos x is sin x. But do you think that's the only function which gives me sin x when you differentiate, which gives me cos x when you differentiate with respect to x? I mean, see, this comes out of our knowledge of the following. d dx of sin x is cos x. So the answer to this question is sin x. Integral cos x dx means the right hand side would be, this would be equal to the answer to this question. This would be equal to the answer to this question. Find a function which when differentiated with respect to x gives me cos x, right? Gives me cos x. The answer you know is sin x. So the right hand side could be sin x, but is that the only function which when differentiated gives me cos x? What else? Yeah, in fact, do you realize that d dx of sin x plus 4, when you differentiate this, what is it that you get? Cos x, because d dx of sin x is cos x and d dx of 4 is 0. Derivative of a constant is 0. So this also gives me cos x. In fact, if I said d dx of sin x plus 11.514, what is this? Cos x. d dx of sin x plus square root of Avogadro's number. What is this? Cos x. How many functions exist which when differentiated with respect to x giving me cos x? Infinite. In fact, infinite. So the answer to this is not just sin x. The answer to this is sin x plus 1, sin x plus 1.2, sin x plus 3.8, sin x plus root 2 plus root 5 plus root 7, sin x plus root 2 whole to power 5 into root 3 to power 7 into root 5 to power log x, log 2, etc. Whatever, right? So now you can't write all of these. How many are you going to write? I mean, you can keep doing that forever and do nothing else, and yet you will fall short of time, right? You won't have enough time to write even a fraction of what you could have written. So what you might want to write is, well, you might want to say it's not just sin x, but say sin x plus c, where c is referred to as an arbitrary constant. C is referred to as an arbitrary constant. Arbitrary constant. C is an arbitrary constant. Arbitrary constant. C is an arbitrary constant. You have the luxury of assigning any value to C and it's fine. Right? C is an arbitrary constant. Right? So any function of the form sin x plus c, any function of the form sin x plus c where c is an arbitrary constant qualifies for this. This function, where c is any arbitrary constant when differentiated with respect to x, will give me cos x irrespective of the value of c that we assign, right? So the answer to integral cos x is not just sin x, but in general sin x plus c, where c could also be 0, leading to sin x as a special case. Are you all there with me on this? So it's like one thing, when I write ddx of sin x plus c equal to cos x, when I write ddx of sin x plus c equal to cos x, this is called the derivative, right? The output obtained out of differentiation is called the derivative. And this is called the primitive. This is called the primitive. This is called the primitive. Whatever you are differentiating is called the primitive. The output of differentiation is called the derivative. In differentiation, you are given the primitive and you find the derivative. That's the process of differentiation. In integration, you are given the derivative and there is an inquiry about the primitive, right? In differentiation, you are given the primitive, given a function, differentiate that. Whatever you are differentiating is the primitive. The output of differentiation is the derivative. So differentiation involves having knowledge of the primitive and finding the derivative, whereas integration involves knowing the derivative. You'll have to go back to the primitive. You'll have to find a function which, when differentiated, gives you that function. That's integration. So integral cos x dx means find a function which, when differentiated with respect to x, gives me cos x. You know that the answer is sin x plus c in general, right? Now, suppose I ask you this. Integral sec squared x dx. What would this be? Tan x plus c now. It's not just tan x, but tan x plus c, which when differentiated with respect to x gives me sec squared x. Okay, now if I ask you integral e power x dx. Absolutely. If I ask you integral 1 by x dx plus c. Right? If I ask you integral sin x dx. Minus cos x. In fact, it's minus cos x. If you differentiate minus cos x with respect to x, you get sin x, because cos x gives me minus sin x. So minus cos x will give me sin x. So integral sin x dx will not be cos x, but will be minus cos x plus, of course, c, an arbitrary constant, right? Right? Integral cosec squared x dx minus cot x, because if you differentiate minus cot x, you get cosec squared x. If you differentiate minus cot x, you get cosec squared x. Integral sec x tan x, sec x plus c, right? Integral cosec x cot x plus c. Now, Let me formally build up the results for you. Okay. Realize that GDX of sine mx, what would that be? M cos mx, because outermost cos mx with respect to x would give me m, right? So it's going to be m cos mx. Right? Now, let me bring this m here. Right? M is a constant, so is 1 by m. And then this 1 by m has a thoroughfare into the derivative sign. It can walk in at will, scoop out at will. Right? A constant. Realize that ddx of a constant a into y, if a is a constant, then this a can come out. That's going to be ddx of a into ddx of y. Right? Similarly, this a can also walk in. When walks in, it assumes this form, right? So a constant can come in and go out. So then this 1 by m can come in. This 1 by m can enter this. This 1 by m enters this, giving me this ddx of sine mx by m, where m is a constant, is cos mx. How about it? Right? Right? ddx of sine mx by m plus c. What would that be? Cos mx, because adding a c is like ddx of c, which is 0. So that's still going to be cos mx. Tell me if it's fine with you so far. Right? Now my question to you is, integral cos mx dx. Find a function which, when differentiated with respect to x, gives me cos mx. What's that function? Plus c. Sin mx by m plus c. Plus c. Right? This is one standard result. Integral cos mx dx is sin mx by m plus c plus c. So if I said integral cos 4x dx, what is it going to be? Sin 4x by 4 plus. Right? So that's result number 1. Integral cos mx is sin mx by m plus c. Similarly, I hope all of you are there with me on this. Integral. Now I want you to check all of this. Alright. 2. The result number 2 that I claim is sin mx dx is minus cos mx by m plus c. How would you know the sanctity of this result? If you differentiate this with respect to x and you get this, then you know that this result is in good faith. Right? How would you know if this result is true? Differentiate this with respect to x and see if you are getting this. This means what? Find a function which, when differentiated with respect to x, gives me sin mx. I claim it's this function. So differentiate this with respect to x and see if you are getting sin mx. All of you, please do that. Differentiate the right hand side with respect to x and see if you are getting sin mx. Yeah. See, ddx of minus cos mx by m plus c is ddx of minus cos mx by m plus ddx of c. But ddx of c is 0. And this minus 1 by m can come out because that's a constant. So minus 1 by m into ddx of cos mx. Hey, this is like a minus 1 by m cos mx. Go from outside to inside. Minus sin mx. And then mx with respect to x is m. So that makes it sin mx. So indeed, when you differentiate the right hand side with respect to x, you get sin mx. Are you all there with me on this? So this is true, right? So this is result number 2, which you may want to remember. Integral sin mx dx is minus cos mx by m plus c. 3 integral sec squared mx dx is tan mx by m plus c. These are all results that you have to remember. Would you want to differentiate the right hand side and see if you are getting sec squared mx? Can you do that? Please do that. Differentiate the right hand side with respect to x and see if you are getting sec squared mx. And once you've checked this, check this one also. Integral cosec squared mx dx is minus cot mx by m plus c. Check this one also. Right. Thanks. Oh my. Have you checked 3? Have you checked 4? Five. Sec mx tan mx dx. You should be able to guess this now. Sec mx by m plus c. Check this. Check this then. After 5, check this. Make sense so far? Right? Integral e power mx dx is e power mx by m plus c. check this. Integral x power n dx is x power n plus 1 by n plus 1 plus c, where n is a constant, not equal to minus 1. Why? Because if n were to be equal to minus 1, this would be rendered undefined, right? So check this. So when you want to check this, you want to differentiate this with respect to x and see if you are getting x power n, right? That's how you're going to check this. So differentiate the right hand side so as to get x power n. If that happens, you want me to show you how to deal with it? Other than 8, are you done with everything? I claim x power n dx is x power n plus 1 by n plus 1 plus c. Now, do you remember the result? ddx of x power something, where something is a constant, is m into x power something minus 1. See the result, right? Now, ddx of x power n plus 1 by n plus 1 plus c. This is what you want to check, right? Which is ddx of x power n plus 1 by n plus 1 plus ddx of c. But ddx of c is 0. Now, this 1 by n plus 1 can walk out. 1 by n plus 1 into ddx of x power n plus 1. Hey, ddx of x power m is m into x power m minus 1, where m here is n plus 1, right? So this is going to be 1 by n plus 1 m into x power m, this minus 1, n plus 1 minus 1 is, so that makes it x power. So when you differentiate this with respect to x, you get x power n. How about it? So, but then this result is true only when n is not equal to minus 1. Why? Because n equal to minus 1 would disqualify this. Division by 0 is not permissible. N not equal to minus 1. Fair enough? But, so this was result number 8. 9. What when n is equal to minus 1? When n is equal to minus 1, this becomes x power minus 1, that is 1 by x. This is the case which this could not deal with. That is, when n equal to minus 1, you could use this result. So you have 1 by x dx. But what's 1 by x? ln x. ln x plus c, right? ln x plus c. In fact, to be technically correct, I would write, see, x could have been positive or negative. And then if x is negative, ln of a negative number is not defined. So what we do is, customarily, we put ln of mod x. So as to obliterate the presence of negativity in x, the modulus is put up so that we have to take logarithm only of a positive number, right? So ln of mod x to be stricter. Are you there with me on this? So that's the result number 9. One by root 1 minus x squared dx. Sin inverse x, yes. Sin inverse x plus c. Did I differentiate tan inverse x for you in the class? Okay. So then, of course, 1 by 1 plus x squared dx is tan inverse x plus c. Right? Yeah, why not? Let me differentiate the right hand side, e power mx by m plus c. It's ddx of e power mx by m plus ddx of c. ddx of c is 0. This goes away. Now, this 1 by m comes out. ddx of e power mx, right? This is 1 by m. Now, chain rule. Outermost is e power, so that's e power mx. Then innermost is mx. mx with respect to x will give me, makes it e power. Right? Can I wipe this off? Have I differentiated sec inverse x for you? Okay. Then you should be knowing this. X squared minus 1 dx is going to give me sec inverse x plus c. So far so good. Can I wipe this off? Now these are a bunch of results in level 0 of integration. Obviously you have to remember all these results. What you want to do is you can sip a soft drink here and go through these results again, the basic results on integration that I wrote for you on the board. You might want to browse through them, and then I'll tell you a set of rules on integration. Will not hold you back for very long because I do understand your concerns about getting hungry at this time, 1 o'clock, and also getting a little angry because so many reasons. Some of you take an afternoon siesta. Some of you might have had other plans on the premise and pretext that the class would be discharged at so and so hour. So given all of this, I'll make life a little easier for you today. Go through all these results, and somebody would serve you a soft drink to sip properly. All right. Now, certain basic rules of integration, just 5 minutes. One thing is a times f of x dx, where a is a constant. If a is a constant, this a can come out of the integral sign. This would be a times integral fx dx, where a is a constant. That's rule number 1. That means if I want to integrate 2 cos 2x dx, then this 2 can come out. 2 times integral cos 2x dx. This 2 can come out of the integral sign. Alright. Rule number 2. Integral of the sum or difference of several functions. Let's say f1x plus minus f2x plus minus f3x plus minus fnx. Sum or difference of several functions. Integral of the sum or difference of several functions would be integral of f1x dx plus minus integral f2x dx plus minus integral f3x dx plus minus integral fnx dx. Which means, suppose I had integral cos x plus integral of cos x plus sin x, for example. That's going to be integral of cos x plus integral of sin x. Integral of the sum or difference of several functions would be sum or difference of the integrals. Let us solve. Sometimes you're going to encounter this integral dx. Dx is like x power 0. This is 1 into dx, which is x power 0. And the result for x power n dx is x power n plus 1 by n plus 1 plus c. So in this case, n is 0. So this is going to be x power 0 plus 1 divided by 0 plus 1 plus c, which is x plus c. So integral dx is going to be x plus c. Time and again you're going to encounter something like this. Right?